Hi, in this video we are going to talk about Josephus problem. The problem says that there are n people standing in a circle. We need to kill kth person in every iteration, and this has to be done in a circular manner. After repeatedly doing it, we need to find position of the survivor. Let us understand the problem better with this example. We have 7 people in a circle and we need to kill every third person. So here are the 7 people. We consider the position of first person as 0, second person 1, third person 2, fourth person 3, 5, fifth person 4, then fifth and then 6. So we have positions from 0 to 6 for 7 people. Now we want to kill the third person beginning from 0. So the first killed person is always the k minus 1th person. The person with position or index is k minus 1. So this is 0, this is 1 and this is k minus 1, right? 2 person. We kill this person. Now we have 6 person in the circle arranged in this way, right? So initially we had 7 people. Now we have 6 people. So we hand over this pistol to the next person, and this person kills the kth person from its own position. So it considers himself as the first person, then the next person, then third person is killed, right? So person with index 5 is killed next time. Now the pistol is handed over to this, and first, second and third person is killed. You can see that third person is killed. The person with index 1 is killed next. Now pistol is handed over to this person, and this person again kills the third person from here. First, second and third. So this person 6 is killed. Now pistol is handed over to the next person, and this person kills the third person from here. First, second, third. So the person number 4 is killed in the next iteration. And pistol is handed over to person number 0. So person number 0, it kills the third person starting from himself. First person, second person, third person. So this person kills himself, and the survivor is person with index 3 or position 3. In this problem, we are going to consider positions beginning from 0, and we need to find the position of the survivor. So the survivor in this example is 3. So for this input, n equal to 7, k equal to 3, output is 3. Let us take a look at another example. We are given n as 4 and k as 2. So persons are numbered from 0 to 3. 0, 1, 2, 3 in a circle. And the pistol is always with the person number 0. So what it does, it kills the second person. First person himself, second person is 1. So in first iteration, person with position 1 is killed. Now your new circle contains 3 persons, 0, 2 and 3. And pistol is handed over to 2. So what 2 is going to do, 2 is also going to kill the second person. So 2 himself is the first person and second person is 3, right? So when k is 2, every person is going to kill the person next to him, right? So 3 is going to be killed in the next iteration. Now you have 2 persons, 0 and 2, and pistol is going to be with 0 because this person got killed, and when a person gets killed, the person hands over the pistol to the next person. So 0 gets the pistol and 0 is going to kill the second person from its position. So first person is 0 himself and second person is 2. So person with position 2 dies and the survivor is 0. So that is why output for this input is 0. Now please pause this video and try to write down a recursive solution yourself. You mainly need to write a function that takes 2 parameters and returns an integer value. Say I'm calling it Josephus, Jos for Josephus, and int n, int k are the 2 parameters to it. And this function should return the position. For this input, it should return the value 0. You need to think in terms of recursion. Before we talk about recursive solution, let us do one more example. In this example, I have considered n as 5 and k as 3. So we are going to kill every third person. Initially, we begin with 0, right? So the third person here is first, second, third. So the first person killed is 2. Then we hand over the pistol to the next person and we kill the third person. So when 2 is killed, it hands over the pistol to 3. And third person is killed again. First, second, third. This time 0 is killed. And pistol is handed over to 1. And now again third person is killed. So 1, 2, 3. This is killed. Now pistol is handed over to 1. And what 1 is going to do? 1, 2, 3. So 1 is going to kill. So the survivor is 3. So for this input, our output is 3. 3 is the survivor. Now think of a recursive solution, considering this example in your mind. If you think of recursion, you need to think in terms of smaller problems. What happens when you kill one person? Number of persons, n, it reduces by 1. So when you make a recursive call, you are going to make a recursive call for sure with n minus 1, right? Initially, n is 5. Once a person is killed, it becomes 4. One more person gets killed, 3. One more person gets killed, 2. And then it's going to be 1 person in the end. So your n reduces by 1 in every recursive call. What about k? Is k going to change in the recursive calls? We always kill the third person in every recursive call, right? So k is going to be remaining as it is. So in the recursive call, we are going to keep k as it is. What about the base cases? You are reducing n by 1, right? So your n is say 5, you will make it 4, 3, 2, 1. When will you stop? When n becomes 1. And what will be your output when there is only one person in the circle? When there is a circle with n equal to 1, whatever k is, what is going to be your output? If k is 1, this person is going to be killed, the person number 0. If k is 2, then also this person is going to be killed. If k is 3, then same person. So if n is 1, then output is going to be 0. We are not done yet. We still need to do some more computations. So just writing this function is not good. Let's see why this much is not good enough. We need to make some changes here. We need to modify this expression. The reason for this is, once you kill this person, when you are doing it manually, you consider the numbers as 0, 1, 3, 4. But in the recursive calls, it's going to be a fresh recursive call and going to consider the numbers as 0, 1, 2, 3, not 0, 1, 3, 4, right? So in the recursive call, the numbers are going to be 0, 1, 3, 4. And it's going to return the output with reference to these numbers. And when you make one more recursive call, these numbers are going to be 0, 1, 2. And it's going to return the output with reference to this. And when you write one more recursive call, it's going to number them as 0, 1. And when you make one more recursive call, it's going to consider one circle with number 0. So the output that you are going to get is always 0 if you write simply this code, right? So you need to do something more. Now please pause this video, do some examples yourself, like n equal to 7, k equal to 3, this particular example, and think of an expression that you need to write here, the changes that you need to make here in this expression so that you get the correct answer. You mainly need to consider your recursive calls with 0, 1, 2, 3 only, right? Now whatever value you get from these recursive calls, you need to adjust these values according to your final output, according to your circle which has 5 people in this example, right? So you need to adjust the output returned by this recursive call, and this recursive call needs to adjust the output returned by this recursive call. Similarly here, similarly here. So what adjustment you will make in the returned value so you get correct value numbers according to your original circle. Please pause this video, do some examples and see what adjustments you will make in the value returned by recursive function calls. When we make our initial recursive call, we make the recursive call for this example as 5, 3, right? And we expect the output as 3, right? That's what is expected from this recursive function. Now when you make the recursive call for n minus 1 and k, which means you make the recursive call for 4, 3. And if you solve this problem for 4, 3, what is the output that you are going to get? So 0, 1, 2, 3. There are 4 people in the problem of 4, 3, right? That is your sub-problem that you are going to call in the main recursive call. This is your main recursive call and you are going to call 4, 3 in it, right? This is something we decided that n reduces by 1 but k does not change. So this is for sure that we need to make a recursive call for n minus 1k. Now we are trying to find out what is the relation between Josephus of n minus 1k and Josephus of nk. For that we are doing this example. So 4, 3, we are going to try what is this get, although I have written the output 0 here. So when I say Josephus 4, 3, it means I am going to make an independent call and this 4, 3 is going to consider the circle as this, right? Not as the circle after killing the third person, right? Not the circle of 0, 1, 3, 4, but a circle of 0, 1, 2, 3 because it's an independent call. And what this 4, 3 will do, it will, let's see how do we got 0? It kills the person number third first and then pistol is handed over to this and this kills the third person. So this person is killed. Pistol is handed over to this and this kills the third person. So for first, second, third, this person is killed. So 4, 3 gives us the answer as 0. So this recursive call gives us 0. And what do we want? We want 3. Right? So how do we get this relationship between 0 and 3? Let's see one more example. Let's talk about 4, 3. So what is going to happen in 4, 3? In 4, 3, it's going to make a recursive call to 3, 3. Right? If you have 4, 3, you are going to make a recursive call for 3, 3. And what happened in 4, 3? Our output was 0. What does 3, 3 return? Let's solve it for 3, 3. Is 0, 1, 2, right? So I'm considering independent calls, right? I'm not, killing it and then making a circle of 0, 1, 3, right? Because this recursion runs independently. We just need to find the relation between the returned value by the subfunction call or the recursive call and the actual return value to be returned as an output. So what will 3, 3 return? 3, 3 will kill the third person from here. So this person is killed. Then kills the third person from here. So this person is killed. And it will return the output as 1. So Josephus of 3, 3 returns 1. And what do we want in 4, 3? We want 0, right? So that's one more hint for us to guess the relationship. Now if you solve for Josephus 2, 3, what is going to happen? It's going to be an independent problem with numbers as 0 and 1. And who is going to be killed? First, second, third. This person is going to be killed. So Josephus 2, 3 returns 1. Right? So here we are actually getting matching values. But can you do more examples of this form like 7, 3 and try to guess the relationship? In this diagram, I have written some example relationships between the returned value by the call 4, 3 and the returned value by the call 5, 3. So 5, 3 is going to call 4, 3 and whatever 4, 3 is going to return, it's going to do some adjustment. So let's take a look at this 5, 3 problem again. What happens? You kills the kth person, which is having in position k minus 1 in the first iteration, and then you call for 4, 3. So when you call for 4, 3, you have the same problem, but positions are not same. The person with initial position 3 now becomes person 0. So this is the same person here, right? And position 4 now becomes position 1, right? This is the relationship. And position 0 now becomes position 2. And position 1 now becomes position 3. So if this recursive call for 4, 3 returns 0, it means your main recursive call should return 3. If this recursive call returns 1, your main recursive call should return 4. So this is the result of this recursive call, and we want to know the result of this recursive call. Please see if you can get some hint from this example. You may pause this video now. Now I'm going to talk about a general example which I've drawn here. So what happens? In the initial problem, you have a circle of n people, right? And then you have a solution for n minus 1 people. In the recursive solutions, we assume that we have solution for n minus 1, right? Now just need to know how do we connect the solution of n minus 1 with the solution of n. Let's see the connection. Let's try to guess the connection. So what happens in the first killing? K minus 1 person is killed, right? Here, for example, when K is 3, person number 2 is killed. And person within position K or index K becomes 0 now, right? So 0 is K, 1 is K plus 1, 2 is K plus 1, K plus 2, I is K plus I. So if this recursive call returns 0, you need to return K. If it returns 1, you need to return K plus 1. If it returns 2, you need to return K plus 2. If it returns I, you need to return K plus I. So you must have guessed that it should be plus K here, right? It should be plus K here. But there is still one more thing to be done. See, the result should be from 0 to n minus 1, right? This value is 0, this is 1, and this is n minus 1. And this K plus I can become more than n. For example, when you are reducing the problem, your n will become actually first n minus 1, then n minus 2, then n minus 3. It will become 2, then 1, then 0, even for k is equal to 3. So if you add k to a number, it will become more than n. So you need to do modular arithmetic. You want the numbers from 0 to n minus 1, and your numbers are shifted by k. So what do? You do modular n. So these are the positions that you want to return. So if your recursive call returns I, you need to return k plus I modulo n, right? K plus I modulo n is what you need to return. Your recursive call returns n minus 1k, you need to return n minus 1k plus k modulo n, right? That's what you need to return in the main function. Here is the final code for Josephus problem. We have the function which takes n and k as parameters, makes a recursive call for n minus 1, right? Does not change k in the recursive call. Whatever it returns, adds k to it because positions are shifted by k, right? In the recursive calls in the sub problem, and then does a modulo division by n because you want the overall result to be there from 0 to n minus 1. On the right hand side, I have done a dry run of this function. So when you call for 5, 3, what happens? It makes a call for 4, 3, right? Adds 3 to it, right? The same expression is being added, does a modulo 5, right? Then this 4, 3 calls 3, 3, adds 3 to it and does modulo 4 because n is 4 here now. This 3, 3 makes a recursive call to Josephus 2, 3, adds 3 to it, does a modulo division with 3. This makes a recursive call to Josephus 1, 3, adds 3 to it, does a modulo division by 2 because n is 2 now. So this is going to give you result as 0 because we have the base case for n equal to 1 as 0. So when it returns 0, 3 is added to it. So you get 0 plus 3 modulo 2, which is 3 modulo 2, which is 1. 1 plus 3 modulo 3, 4 modulo 3, which is 1. 1 plus 3 modulo 4, which is 4 modulo 4, which is 0. 0 plus 3 modulo 5 is 3. So you get the answer as 3 for this input. And this is how this function executes. Let us analyze time complexity of this implementation. So if the time taken by this function for an input n is tn, then tn is going to be tn minus 1 plus some constant work, right? Because it simply makes a recursive call for n minus 1 and does some constant operation and finds the value. So how much is the value of this recurrence? It's simply theta n, right? We can compute it by drawing the recursion tree. C will come at the top, then tn minus 1, right? And if you break the recursion tree further, you will have C, C and tn minus 2. And if you keep breaking, you will have many C's, right? C, C. And how many C's you will have? You will go till n equal to 0. So it's theta n, right? There will be theta n C's. You're reducing n by 1 in every recursive call. So the time complexity of the solution is theta n. Now an interesting extension of this problem. Say your circle positions do not begin with 0. They begin with 1, right? So this position is 1, this position is 2, this position is 3. So if you are given 5 people in a circle and if you have to kill every third person, in the previous example we were getting the output as 3, but here we will be getting the output as 4, right? Because the positions begin from 1. How will you solve this problem? So I have written a simple solution of this problem. The idea is simple. I'll call this function which returns the values from 0 to n minus 1, right? And I will write one more function that simply calls it and simply adds 1 to the result. So if this function returns 3, it will return 4. If this function returns I, it will return I plus 1. And this function is going to consider the positions from 0 to n minus 1. So it's going to consider 1 as 0, 2 as 1, 3 as 2, and n as n minus 1. So whatever this returns, you simply need to add 1 to the result, right? And that way you can solve the problem of Josephus where indexes begin from 1.